亲爱的嘉宾朋友们，大家晚安，大家好，欢迎各位莅临创新创业与循环经济之未来性论坛。活动即将在5分钟后7点钟正式开始，请各位嘉宾们准备就座，并请关闭您的行动电话或者调为震动模式，以维护活动的顺畅进行。感谢您的配合，敬请稍待片刻。各位来宾晚安，非常感谢大家今天的莅临。今天的创新创业与循环经济之未来性论坛就在今天的7点钟准时开始。今天也有非常多出席的重要嘉宾，也请待会唱名道的嘉宾可以起身向现场的所有贵宾朋友们挥手致意。首先让我们欢迎到的是循环台湾基金会代表陈慧玲陈代表，欢迎。 的是中原大学产学营运总中心王世明副执行长，欢迎。待会呢，王副执行长也会再次来到我们的活动现场。接下来欢迎到的是中原大学创新育成中心林淑荣主任，欢迎。谢谢林主任的莅临。那再次跟所有的长官、嘉宾以及所有的同学们，大家晚安，大家好。欢迎各位参加由桃园市政府青年事务局主办，并且由中原大学执行的创新创业与循环经济之未来性论坛。循环经济在世界的经济以及环保运动的发展之下，成为一个非常热门的议题。人类的各项经济活动当中，未来都需要从线性经济朝向永续经营方向来进行。本次的活动当中，我们也特别邀请到国内外的专业讲者，并且透过专题演讲以及互动研讨方式，让社会大众更加认识循环经济的缘起，以及实践之后所带来的环保以及社会效益，并且透过循环城市的案例探讨，了解应用在其他城市当中以及桃园区域，创造出新的可能，让桃园的产业可以持续的创新以及成长。所以在我们首先今天的第一个主题当中，我们要以热烈的掌声来欢迎我们循环台湾基金会陈慧玲陈代表为大家上台进行循环经济介绍。掌声欢迎陈代表，欢迎。
喂，听得见吗？可以。大家好，我仅代表循环经济基金会，那谢谢大家的莅临，那非常感谢大家，就是你们晚上都没有去 party， 然后来这里坐在这里。那今天我想请问一下，来的有哪些是中原的学生？大部分都是中原的学生，有没有是外校的学生？哇，你是哪里的？哦 ，A 嘛。对，好，我知道。那有没有一些是青创企业家？听说今天，好，所以今天大部分都是学生。那我想先跟大家讲一个小故事，是关于我的小故事。那我离开大学有点久了，但是我是刚从荷兰回来。那我在1-2个月前跟大家那个准备期末考一样，就坐在图书馆里面，就是赶我的论文这样子。那我想跟大家分享一下，就是说为什么我就是重回学校，所以我大学是在成大念的，然后我的硕士是在荷兰还有奥地利念的。那其实我是一个工业设计师，那我想这边现场应该有蛮多建筑系还有景观设计的学生，所以我想要跟你们分享一下，就是说为什么今天要带来这个主题循环经济。那我以前设计过很多产品，所以我以前在设计公司工作，所以设计过很多手机，大家用的 USB， 然后数位相机、家用品、玩具、家具我都设计过。那以前做手机的时候很夸张，就是这个月绞尽脑汁，想出一款手机以后，下个月又要再想一款新的，又要再想一款新的。所以我后来我就想说，为什么我们要一直设计的新产品？对，那这个新产品呢，就是为了要让消费者买更多，因为你们不买，厂商不会赚钱。所以在我们设计产品的时候，我们就会把这个东西设计得很容易坏掉。所以那个大家手机的按键，你可以按多少次，这个我们都已经设计进去了。那个边角多久以后就会磨得不太好看。对，那这个过一阵子呢，厂商就会出新机款。对，然后你就觉得我好逊哦，我同学都买最新的机型。所以你就想要把你的手机丢掉，然后再换一款新的这样子。那衣服也是一样，服装产业也是一样，就是过一阵子大家要流行红色，然后你就觉得我穿蓝色好土哦，所以你就再重新换。那下个月又流行黑色，所以你就又换黑色。那其实这些我们的生活都已经被设计进去了。那时候我就对绿色设计非常有兴趣，我就觉得我们这样好像不行，那我们的产品应该要设计的非常的环保，设计的非常绿这样子。但是我开始这样做以后，我就发现，不对，如果我的产品设计的很容易回收，可是公司不回收怎么办？那如果这个消费者他还是想要一直换新机怎么办？那这个回收来以后到底要怎么处理？所以我就发现，产品的问题不是在设计，是我们整个系统都必须要被设计，我们的社会、我们的经济都需要被设计。 所以这就是为什么我后来到荷兰去学习，我念的科目叫工业生态学，那其实就是我们今天要讲的主题——循环经济背后的科学。那为什么我要去荷兰念循环经济，就是这方面的科学？就是因为循环经济是一个重新设计这个系统还有这个社会的一个方法，这样子。那所以呢，今天循环经济，就我们基金会是由黄玉珍黄董事创立的。那他其实是一位退休的这个企业家。那他看到台湾的社会有很多的问题，失业率啦，大家22K 啊等等，就是还有这些社会上有很多的环境污染等等的问题。那他就是想要为大家引进现在在世界上还有欧洲最热门、最火红、最重要的一个经济的概念，叫做循环经济。那今天来的这几位专家，基本上4位是荷兰人，那其中有1位是美国人。那为什么想要介绍一下荷兰这个国家？我想大家应该在报纸上都会看到，就是说为什么台湾要跟荷兰取经？因为荷兰跟台湾非常的相像，荷兰是一个地小人稠、没有什么资源的国家。那为什么他们会变成世界强国呢？是因为我觉得他们是一个很有远见的国家，所以他们想得很远，他们知道自己没有资源，在世界上的舞台要怎么样才可以永续的生存下去，找到自己的竞争力。那循环经济也是他们想出，而不是他们想出来，是他们推广的很大的一个就是议题，就是说让我们的系统、我们的资源都在这个社会里面循环，就好像大自然，我们其实是没有废弃物的嘛。所以大概一棵树，它的树叶落下来，就变成这个土地上的一个就是养分，对不对？又回到了大自然里面。但我们的人，就是我们的社会里，却有很多的废弃物。那所以今天呢，我就其实这一次的机会真的是非常非常难得，大家真的都非常的幸运，因为这些人他们在荷兰都不会聚在一起的，你就算到荷兰也不会看到他们同坐在一堂。那这次是由桃园市政府，他们非常有心，他们想要把这个概念带进台湾、带进桃园的时候，他们觉得第一步要先教育市府的同仁，让我们的政府跟我们的地方一起携手合作，所以他们才花了很多的精力，那把这些专家请过来，那也是他们的一番心，就是说觉得我们的年轻学子必须要就是有新的概念这样子，所以大家今天非常的幸运这样子。那我今天先为大家介绍前面2位讲者，这个是第一位讲者是 Miss Eva Gladek， 那她是这个 Metabolic 这个顾问公司的创办人，还有 CEO。那这个是一个在也许他待会会自己讲。那但是他就是一个在荷兰非常年轻，但是他们的业务拓展的非常快的顾问公司。那他们帮公司、企业还有地方都做很多顾问、循环经济的顾问服务。那第2位呢是 Mark de Wit， 那他是荷兰的一个社会企业，那他们是一个非营利组织，但他们致力于就是推广循环经济，所以这2位都在实务跟理论上都有非常多的经验。那我们现在就不多说，就邀请 Eva 上来为大家介绍一下循环经济。
Thank you very much, Shadow. Can someone tell me? Okay, there's also a pointer. Great. Okay, well, it's a pleasure to get to talk to you all today. Before I start my presentation, which is going to be about the circular economy in general, and also finding action areas and leverage points for moving to a circular economy, I wanted to just ask you a couple of questions. First, I wanted to know, could you raise your hand if before this presentation series you had heard the term circular economy before? Raise your hand if you had heard it. Okay, so 2 people. That's not that many. So that's good to know. And another question, how many of you know what you want to do for your career? Raise your hand if you know what you want to do for your career. Nobody. Okay, 1 person. Well, that's good. Okay, because that's good, because I hope that maybe some of these things can also inspire you to think about your career and how to shape your future, because a lot of my journey for moving towards working in a circular economy was also a personal story about moving away from being a scientist. So very quickly, where do I need to point? This is, oh yeah, it's working. Okay, so this is a quick overview of my talk. First, I'm going to tell you a little bit about my company, about Metabolic. Then I'm going to very quickly explain the basic concept of the circular economy. Then I'm going to talk about a study that we did, looking at how circular is our current economy, because we decided to analyze where the change points are that are necessary. And then I'm going to highlight a few key global challenges for moving towards circularity. So first about my company, and a bit about my personal history. So Metabolic is a systems consulting and clean technology development company. I actually started out my career when I was 13, working in a laboratory. I was going to be a research scientist. So my plan was that I was going to be a biologist, and my parents said, okay, you're going to be the next Marie Curie. This was their plan. And I also liked the plan because I loved biology, I loved research. But as I went through my career and also started studying more and more detail in molecular genetics, I realized that I was getting farther and farther away from societal problems. And I was stuck in a lab all the time doing very specific research, becoming an expert on one species of slime mold. And at the same time, I was realizing that there were so many societal problems that I thought I should address. So I started to move in the direction of more societal-focused issues. Always looking for more opportunities for impact. First, I became a science journalist. I was making news about science for ABC and NBC News. And then I decided to go back and study industrial ecology, the same thing that Chado studied, Ms. Chen, except at Yale University in the United States. And after I finished my degree, I started my first company, which was a sustainability consulting firm. So I thought, okay, finally I will get to advise people on how to be sustainable. And after many years of doing that, I also got frustrated that people were not taking my advice. I would give a great design or a report, and they would say, oh, thank you very much, this is wonderful. They would talk about it in the press, and then they wouldn't do anything. And so 3 years ago, I was frustrated, and I said, okay, I'm going to start a company that actually does sustainability work. And that's when I started Metabolic, and met many great colleagues, including Sandy, who is going to speak to you later about some of our work. So our mission is to fundamentally transform the global economy to a sustainable state, and the circular economy is a theme that we have adopted as one of the main ways to explain what we mean by this. So we have 3 divisions within Metabolic. The first division is focused on systems analysis and consulting work. We do a lot of work for companies, so we look at their material flows and figure out how to optimize them, but always we're looking at analyzing and developing visions, designs, and then implementation. So it's very focused on that direction. And this is a picture of some work we did for a textile fashion company in the Netherlands. The next division that we have is the technologies division. So this is where we actually prototype and design technologies that we want to implement, and we do a lot of experimentation. This is an urban biorefinery that we built in Amsterdam, and if you ever come, you can come and visit. And then the last division is the ventures division, which is where we actually build new companies that focus on specific markets. So this is one of the companies that we started. It's called Spectral Utilities, and it provides off-grid sustainable resources to different places like refugee camps or events, so a whole range of functions. And this is a solar transformer, so a hydraulic-powered solar bird that produces solar power anywhere. So basically, our company is an applied industrial ecology company or an applied circular economy company. And the other thing is that, of course, over the last few years, we have focused very strongly on advising governments and companies on specifically circular economy strategy. So this is some work that we did looking at the current linear system in a region in the Netherlands, Friesland, and then all of the potential for how to move towards a circular state and all the ways that you can close these linear cycles. So this is the kind of work that we've been doing for regions. So very simply, what is a circular economy? Well, it's the opposite of a linear economy. So this is a picture from the Ellen MacArthur Foundation, who popularized the term recently. The basic idea is that we are taking natural resources, extracting them, making things, disposing of those things, and then we end up with waste. We've done a lot of analyses to see exactly what this cycle looks like, and globally, we are only recovering around 10% on average of all the materials from this cycle, which is actually already better than it was in the past, but we're losing 90%. So not only is that a big loss of natural resources, it's also a loss of value, of financial value. And so the idea is that the circular economy looks at materials in these different cycles. So we have the biological and the technical cycle. And this is the model that has been introduced by many groups, including the Ellen MacArthur Foundation and McKinsey. One of the big things is, of course, that there's a lot of money that you can potentially make by saving these resources. And that's also why the circular economy has become so popular recently, because people, especially businesses and governments, see that there's a huge economic potential. So this is the common idea of the circular economy that many companies talk about. When we started working on it, though, we started to dig a little bit deeper, and we started to think about whether this was indeed the whole story behind the circular economy. Of course, the value of materials is pretty evident. So this is an iPhone 5. The iPhone 5 has a material cost price, just the materials in this cost $168 US. That's a lot of value. So you can imagine that if you're a company that can get this value back, that's a huge thing. But just getting that material back in a usable form is not necessarily enough to make a fully circular economy. The reason is, okay, here we have e-waste. So in theory, you could get the materials back like this. You could have small children take apart the waste and then get them back. But then would the economy be circular? We didn't think so. This is a picture of mine tailings coming from mines that are used to extract the scarce metals that are used in the products that we have. And again, if the economy is able to circulate everything, but still creates these types of problems, it's still also not circular according to us. And also there's other issues like scarce resource use. So this graph shows how much time we have left of each of these different scarce resources, mainly metals. And in a circular economy, you also have to think about how to allocate these critical resources in a way that is sensible, so that you're not locking materials into long cycles where those materials are not accessible for reuse. So we started to uncover all of these elements of complexity about what a circular economy actually is when you get into materials management. One of the things that is useful to think about for us is the planetary boundaries. So it's not just about cycling materials, it's also about making sure that we don't cross key tipping points in the functioning of the planet. This is work that was done by the Stockholm Resilience Center that shows that global biodiversity, out of all of the boundaries that they identified, is the one that is most crossed. In fact, the World Wildlife Fund reported last year that we have lost 52% of global biodiversity according to their index in the last 40 years. In the last 30 years, we've lost 40% of all mangroves. And these kinds of things lead to a very large lack of systemic resilience. So planetary boundaries are also another issue that we take into account. Basically, we have come up with our own kind of definition of a circular economy, where we say it is a new economic model that functions fundamentally differently from the current economic model, that addresses human needs and fairly distributes resources without undermining the functioning of the biosphere or crossing any planetary boundaries. So this then gives a basis for certain metrics for how to evaluate what is circular or not. Based on that, we also developed these 7 principles for a circular economy. You can read these when I send this to you all later, but just very quickly, in a circular economy, ideally all materials should be cycled indefinitely, so materials should not be put into cycles where they cannot be recovered further. All energy should be renewable. The resources should be used efficiently to generate multiple forms of value. Human activity should support ecosystems and natural capital in a structural way, so preserve biodiversity, strengthen cohesive society and culture. Human health and well-being should be a primary thing, so like the e-waste problem should not occur. And then the system should be inherently adaptable and resilient to shocks. So the question is then, how do we get to this idealized economy, and what does it really look like? Well, there's a lot more detail, but we can't go into that. So how to get there? Because we're systems analysts fundamentally, the first thing that we did was, okay, well, let's analyze the system. Let's understand what about the current economy is not circular? Where are the leaks, at least in terms of material flows, and where are the boundaries that we're hitting that are very critical? So this actually shows for the year 2010, all of the materials that were extracted in different categories. So here we have biomaterials, then here we have fossil fuels, ores, and minerals. And the total amount of material extracted was 117 billion tons, which is around 322,228 Empire State Buildings, if you've ever been to the United States. I'm going the wrong way. So this is this picture visualized in a different way. So you can see all the materials coming from different places. Everything is to scale, except for water, because that would be much bigger. It would be 10 times the size, so we've actually shrunk it down. And what you can see is the materials going into different functions. And actually, a lot of the material that we extract gets dispersed into the environment in a structural way. A lot of it also goes into long-term stock. But one of the striking things is that out of everything that we extract here, this line right here is the only thing that is actually recycled. So it's a very small amount in comparison to this, partly because of the stock and the dispersal, but even out of the materials that are actually going through, we're only collecting around 10%. That's the number that I cited before. So based on this analysis, we started to look at, well, what are the different sectors and where are the real key opportunities for closing these cycles? So here are some key takeaways. I'm only going to highlight a couple. One of the important things to know is that this trend in material extraction is increasing constantly. So it's not like we have stopped extracting materials. It's going up, not quite exponentially, but very strongly. A lot of the material that we extract is actually immediately wasted. Around 40% of the materials, including actually 20% of chemicals and around 0.5% of metals, are actually dispersed into the environment because of the way they're designed. So we actually cannot recover them because the design is like that. So if you think about like an abrasive rubbing material, it's designed to go into the environment, or paint, or road salt, or something like that. Then we have 40 to 45% being put into long-term stock, which is actually very interesting for the circular economy because these are very large amounts of material, but people are not thinking about getting them back because it's later in the future. So that makes it more challenging to actually recover that material. And then around 3.5% go into medium-term cycle of 2 to 15 years, so cars and consumer products like what you have in your kitchen. And only 1.5% of materials goes into the short cycle, so disposable products, packaging, textiles, personal care products, this kind of thing. And so this is actually, a lot of the focus in circular economy discussions is on this area. Of course, not everything, but this is only 1.5% also, so it's important to know. Okay, so in addition to the main problem, one of the main problems of leakages and losses of material, that we're losing a lot of this material, as I said, that only 10% is recovered. We also have structural impacts on human health and well-being, so a lot of new novel entities, nanomaterials, etc., getting into the environment through the selection of materials, and also a disruption of the key planetary boundaries, so loss of biodiversity and disruption of the nitrogen cycle, climate change, etc. So these are actually all issues that we see as part of the circular economy, because unless the economy is functioning within all of these boundaries, it's violating some major issues. So we identified two types of circularity gaps that can be solved, and one of them we call the incremental circularity gap. So this is basically the amount of materials that we can recover by making small adjustments to how we do things already today. And that is, the size of this gap we estimated at 3.4 billion tons per year, so that's around 4.5% of the annual material extraction. And here's just an overview of the different types of materials that can be gained in this way, potentially. And this is basically by improving collection and recycling of waste, by implementing new business models for extended producer responsibility, like leasing. These are all proven things that can be done with existing techniques. And also implementing design for disassembly techniques and more supply chain collaboration. So we call all of this incremental because it has to do with products that are provided in the way that they are now provided, but just with some tweaks so that the materials can be recovered. So here you can see a fully disassemblable laptop that was made by Autodesk. And this is another example of design for disassembly. These are only two of the kinds of innovations that you can apply to gain all of these incremental circularity gaps. Then there's the disruptive circularity gap, which is much larger, and this has to do with conceptualizing how to provide services and actually how to restructure the functioning of the economy in a completely different way, so that a lot of these gaps don't come to exist in the first place. A lot of these problems don't come to exist. So as I said, it's much larger. It's 15 billion tons per year. There's many more areas of focus, but many of them are much more difficult to actually innovate out. And the directions for solutions are quite different. So it's thinking about products and services in a completely different way. Why would you provide a product instead of a service for certain kinds of things? Also, eliminating the need for certain material cycles because you design completely something different. Or systemic solutions like looking at alternative currency systems that change the actual investment incentives and allow for new types of partnerships to come into existence. So a couple of technical examples that may fall under the disruptive circularity gap are these two. This is an example of lotus end paint, which is a paint that works like a lotus leaf. It cleans buildings automatically because it has a nanostructure actually in the form of the paint that allows water to run off and take dirt, so you don't have to clean. And this is an example of using the same technique that butterflies and peacocks use to color their feathers to color a dress. So through nano interference, actually changing the structure of the fiber, you can actually use color a dress without chemicals. And that's unique because, of course, 20% of the chemicals that we produce are dispersed into the environment, and that's because we've designed them to end up in the environment. With this, you don't need a chemical at all. You can just provide the color without the chemical. There are many, many inspiring examples like this that can already be applied even in this disruptive circularity area. So fundamentally, we need to really rethink the design of the system. So these are just some of the things that we found through our analysis, but ultimately, like what Shadow was saying, that the system needs to function more like an ecosystem where everything works together and all the different flows are connected in a different way. And for that, we need to change mindsets, and we also need new types of tools. I'm not going to get into the details of these types of tools, but I wanted to explain a little bit about how when you think about materials, going beyond just the idea of biological materials and technical materials, there's the idea of why we would use certain materials for certain functions. So for example, if the material is scarce and has very high competing demand and no available substitutes, that means that it should get a very high recycling priority. That means it's very important to recycle and should be put into shorter cycles because that material needs to be used for other functions. And the same can be done for product design. Anyway, we've identified based on our work these areas for intervention for a circular economy, and this is from that global material flow analysis: agriculture, cities and the built environment, wastewater, mobility and transport, electronics, chemicals, and construction and demolition waste. There are many others, but this is based on the analysis that we have done in terms of impacts and size. And my colleague Sandy will later talk about the cities issue. So I'm going to leave you there since I'm over my time. And thank you very much.
接下来我们要邀请到的是下一位主讲者，要为我们带来的主题是循环城市案例探讨、循环都市规划的专题演讲。接下来我们要邀请到的是 Senior Project Manager of Circular Economy, Dr. Mark. 欢迎 Mark.
Thank you very much for your kind introduction, and thanks a lot for the invitation to speak here tonight. Really thrilled to be here. I also wanted to start with a couple of questions just to see what kind of audience we have here tonight, because we were told that you have quite different disciplines, so really ranging from architecture to business to landscape, urban planning, etc. So who's in business studies or anything related to that? Anyone? Architecture? Just one? Urban planning? Environmental engineering? So what is the bulk of you actually studying? Who can give the... Can you say what you study? Civil engineering, is that the key? Industrial engineering? Anyone? Also just one. Well, it will remain a mystery then, because I'm out of flavor. Who studies literature? Medicine? Law? Just anything to do with natural sciences? Physics, chemistry, biology? Raise hands. Who does calculations when they go into study? Use equations to solve problems? I'll ask the question again once I've done my presentation to see whether it makes sense what I'm talking about. So what I want to tell to you today is actually looking at two sides. One is something that Eva spoke about, is looking at construction, and actually share some of the insights of a recent study for Amsterdam, where the company I work with is based. And then also go into the business case and the business side of things. So what is actually hampering why we're not doing things that we could or should actually already be doing. But before I do that, I wanted to say that looking at circular economy, and although just 2 people raised their hands when they said they knew something about circular economy, we actually experienced today when we went with a bus to your beautiful province of Taiwan, which I always pronounce wrongly. But we saw beautiful things, really ranging from the production of electronic parts, really the assembly of that, but also looking at recycling of old lamps, and really recovering the mercury from that. So actually a lot is happening. So I would say you are really, as a province, really on your doorstep, doing so much already that you could call circular, or that are really great efforts in a good direction. So I see a lot of great momentum, and we're only in the country for 24 hours. So I think that says a lot. So a very nice firm basis to start from. So as said, I would like to share some of the insights from the study we did for Amsterdam. There it is. But it's actually, I wanted to start with something that's much more generic. And it also attaches back to Eva's story, which is that we, and I think that the same goes for your province as well, but also in the Netherlands, a lot of the construction of new buildings is very much needed, but at the same time we're also demolishing old buildings with a lot of waste coming from that. And the actual practice in the Netherlands a lot is that on a demolition site you have big containers where a lot of these materials end up in, and they're being discarded as unsorted waste. So you have very large streams that are not actually put to much use. They're very much downcycled. For example, a lot of the concrete waste is being granulated and used on the roads as a fundament, but are not used for concrete and the construction of new buildings again. So how could you really come to closing cycles there? And what I wanted to highlight here, and I don't think it's very much readable, is really looking at the dynamic in a city, also from a spatial element. So what does it mean if you want to use some of the elements that you now get out of demolition activities that you have? So it's indicated here, just tearing down buildings that we put down 50 years ago or 40 years ago, where we had some iron to reinforce the concrete, and it's all molten together, so you cannot really do a lot to very smartly disintegrate the building. And at the same time you have new houses that you want to produce. So how can you come to solutions, and what are the spatial solutions for that? So we conducted an analysis looking at how could you best make that happen. For example, looking at, on the one hand, the new materials that you would need, but the old ones that you have, which are in great disbalance. Probably what you have as demolished waste at one site, you cannot directly use at the other site because the volume differs, etc. So you need to store spaces, so you actually want to create physical places in your terrains where you store it to really provide a solution for that disbalance. You also want to think about what separation technologies do you need to make something useful out of used concrete. And there are many technological opportunities to do so, but in actual practice it doesn't happen a lot. And the other thing, so that's really looking at the current housing stock that we have. On the other hand, there's a design challenge. So how do we design buildings today to make sure that in 30, 40, 100 years we demolish them, or not even demolish them because we can repurpose them. So how do we smartly design structures now to make them adaptable? As I also learned from Taiwan, you have an aging community or an aging population. You're actually a declining population. So probably the demands for housing will change over time. At least that's what's happening in the Netherlands. We see a lot of empty buildings, and on the other hand, we have a lot of homes that we need for the elderly, which require different functionalities. So how can you make that more adaptable from the beginning? I think that's one of the key reasons that you also want to think about it. You have several strategies for that. But as I also pointed out, on the one hand, that may seem very smart, but you also run into spatial implications. So let's say we want to tear down a building very close and we want to use it 10 kilometers further down. Do you then have 1,000 trucks that you need to run from point A to point B to make that happen? How does that look? And can we actually do that? Is there a smart way of using all these different fractions and get them from point A to B? So what are the spatial implications? So what we did is we looked at, this is the city and the metropolitan region of Amsterdam actually. I can zoom, I think, where we looked at some of the empty plots. So highlighted with a circle are current offices that stand idle, that don't have any functionality. Actually, roughly 1 out of every 5 buildings in Amsterdam has no current activity in it, which is really also an economic problem. And at the same time, and that's indicated in blue here, we have great expansion activities planned for the near future. So how can you link the two? That's one of the questions also that the city government is really thinking about, which is really tied to the circular economy concept. I don't see any minutes on the board. Does that mean that my time is up? That was the instruction. Probably not. So I want to move to a bit of the business side of things, as I said. So this is also related to the butterfly graph that Eva showed. So what you could just say is that in the linear economy we extract materials, we make parts or we manufacture intermediate products from that, we assemble products, we actually brand them and assemble them to the final products, and then we use them. And the question is, well, how can you make the smarter use? Because in all these steps we add value to the product and to the services we give around those. So you have actually, and it's indicated in red here, the darker red is the preservation of more value. So you could have the dominant direction that we're going in now, either ending up as waste or recycling it to the main materials, which preserves less of the value. At the same time, you can, after recovery, also reuse, for example, entire parts. So out of that iPhone 5 that was shown, you can go to the material level, but you can also use parts which preserve more of the value. You can reuse or refurbish the entire product, especially for iPhones, which are in high demand. That's a very good idea. Actually, Apple is also doing that. But you can also make them and really design them for longer use. So also from a business perspective, what we are currently doing is really destroying a lot of value because we put in a lot of time and effort in the materials, in the energy, in transport movements, in labor to end up with a product. And we very easily either dispose it or recycle it down to the material level. And in that act, really in this part of the cycle, we destroy complexity. We put all those materials together to give it a functionality, and that's what we destroy. And how can we do a better job in preserving that? So here it's also laid out, so this is the value creation on this axis, so we put in materials, energy, labor, then we have the use phase, and here you see different, actually in hierarchy of the reuse options that you might have that I just showed as well. Well, here the example of a car, but you could also have this to an iPhone or whatever. You have the materials going in here, and then the reuse parts, the harvesting of the parts or the recycling represent a certain value, and actually recycling represents a very small portion of that value. I want to finish off with a tool that we developed to look at different trade-offs in any of these preferred reuse opportunities. So obviously you want to go for the opportunity that has the best reuse value and preserves the most value or complexity, so that you have everything in its functional form. But the laws of current business actually point in a different direction most often. So what we have done here is look at the case of concrete, where you need a lot of materials, like the clay, the granulates, etc., to produce intermediates, and eventually you want to produce concrete to make a building. Well, what can you now do after you demolish that building? You can do many things with it. You can either, and that's the dominant way at the moment, you can granulate it and use it on the roads. You can also granulate it, but then separate it and reuse it again in its material forms. But you can also, through smart design, have just, for example, slabs of concrete that you can use integrally. And what the model allows you to do is to really look at, well, what are the investments, indicated here in red, that you need to do to get it into a functional form. So in this scenario, to granulate it. And in green, it's then indicated, well, what is then the value it delivers from doing that investment. And in blue, you see the margin from that. You see that there are different margins for the different scenarios. And what you're able to do, so you have here a whole panel with input prices, for example, the price of clay, the price of energy, the price of labor, and you can play around with the model to see, well, if we change, for example, a doubling of all resource prices, what would happen in the relative trade-offs between different scenarios? So back and forth, and you can play around to see, well, what actually tips the balance in the direction we want it to go in. And some of the things we explored in here is, on the one hand, changing resource prices that went up tremendously in the past decade and actually came down in recent months. It probably will go up at some point. But also, how can you implement incentives, for example, from the government to also tip the balance? And one of the ideas in the Netherlands that is being advocated for a very long time is a tax shift, actually to tax, instead of taxing labor very heavily, which is done in the Netherlands, actually tax materials, because you want to have more jobs, so you want to really make it very attractive to work, and therefore you want to lower taxes there. Actually, what you want to discourage is used virgin materials, so you can increase the taxes there, which could have profound impacts of tipping the balances here. So a way to explore the balances there. So that's what I wanted to close off with. Thanks a lot for your attention, and I'm looking forward to the Q&A session to get to know what you actually study. But thanks a lot for your attention.
Thank you. 待会大家可以跟他讨论你到底是读什么系的哦。好，来，接下来呢，我们要针对前面两个议题来做一个互动研讨，也请各位现场与会的嘉宾跟同学们可以踊跃的发问，准备好你的提问，把握机会，记得要发问。那记得呢，如果想要发问的同学跟嘉宾，请你举起你的手，我们现场会有工作同仁递麦克风给您，并请同时告知我们工作同仁您的单位以及姓名。所以在接下来的互动研讨当中，我们要再次邀请到循环台湾基金会陈慧玲陈代表为我们主持，欢迎陈代表，欢迎。 接着我们要来邀请到2位嘉宾来担任我们今天的讲员，我们要再次欢迎 Miss Eva 以及 Dr. Mark， 掌声欢迎。来到我们台上，接下来有请现场的嘉宾朋友们尽情发问。
对，那个想要跟大家讲一下，今天的时间真的是非常的珍贵。大家就听到刚刚 Mark 说，他们下飞机不到24个小时就被拖去跟企业家见面，然后今天一早8点半就被我们挖起来去看工业区、去诊断，然后去 RCA 的现职这样子。那所以他们今天都非常的已经有满满的行程这样子，所以时间真的非常宝贵。那请大家就是永远把握机会。有人要问问题？来，你先来。
来，我们现场麦克风。
我把我的麦克，哎。
Okay, when you consult with companies, so how do you go about convincing them to go towards like a circular economy, like a circular way of doing things? Because at the end of the day, it comes to profits. Right? I work in finance, so we look at the numbers. So how do you convince them of that this is a good business case? And like you mentioned before, there's a lot of technologies, but there are a lot of costs associated with how to separate the materials that have been already put together. So how do you convince them of the economic benefit?
I think both of us can probably answer this question. So in many cases, there are opportunities where it is actually economically beneficial to pursue a circular economy strategy. There's this great alignment between what's good for the planet and what's good for the world. But actually, in other cases, it's much more difficult, as you can guess. One of the things that we're looking at is you can actually change the incentives and change the balance by looking at new structures like partnerships. So if a company that is, let's say you're a manufacturer, and you team up with a waste processor, you can both find gains, maybe over a longer term, but you still find gains. One of the big problems with the current economy is that it goes for maximizing economic returns at all costs, and that's one of the problems that makes even beneficial equations difficult to achieve. So I think one of the bigger things for moving towards a circular economy will be to actually change the incentive structures of the economic system. That has to eventually happen. But for now, there's many small-scale and even large-scale benefits that can be achieved.
Maybe to add, we're also working a lot with banks that actually also see this as an opportunity. But what you see, I think, as I've already put, two main elements. One is the short-term focus, definitely with listed companies that have shareholders that are really thinking in 4-year terms rather than the longer term, because a lot of these things require maybe, but definitely not always, higher upfront investments, but that really have a very healthy payback period, which is not